today. For today's video, I'm going to present what I have learned on Chapter 3 Torsion. So now, let's proceed to the video presentation that I prepared. What is torque? Torque is a moment of turning or its twisting moment on structural members. In this formula, we can see the relationship between shear stress and torque. We also have another formula of the polar moment of inertia for solid cylinder, where the amount of shear strain is determined by the angle of twist, the element of the shaft, and the distance along the radius of the shaft. The longer the shaft, the lower the shear strain, and therefore we can say that shear strain and shaft length is inversely proportional. And now, on the next slide, torsion in circular shaft. Simplifying assumptions, compatibility, equilibrium, torsion, power transmission, and statically indeterminate problems. In simplifying assumption, the cross-sections remain in plane, the radius doesn't change, and the length of the shaft remains constant during the deformation. Each cross-section rotates as a rigid entity about the axis of the shaft. We also have compatibility and then equilibrium. On equilibrium, angle of twist is the rotation of cross-section at the free end of the shaft. The angle is obtained by this integration. Angle of twist is used to determine the shear strain in any point along the cross-section. And angle of twist is measured in radians, and it is commonly denoted by the symbol pi. Then we have torsion formulas, where shear stress is acting at the distance from the center of the shaft. In finding maximum shear stress, we replace distance by the radius of the shaft. Take note that these formulas are considered valid if shear stress don't exceed on the proportional limit of the material shear. Then this formula will only applied on the circular shaft that can be solid or hollow. We have polar moment of inertia for solid and hollow shaft. Now on power transmission, when the shaft is rotating with a frequency of F revolution per unit time, we are going to replace formula with 2 pi multiplied by frequency. Then we have this formula where power of rotation of a circular rod is equal to the applied force times frequency of rotation. And lastly, statically indeterminate problems. We have 4 steps to be followed. First step is draw the required free body diagrams, then write the equations of equilibrium. Second step is derive the compatibility equations from the restrictions imposed on the angles of twist. And the third step is use the torque-twist relationship in expressing the angles of twist. And the fourth step is to solve the equations of equilibrium and compatibility for the torque. And that ends my video presentation. Thank you for watching.